Okay. Perfect. I can start? Okay. So thanks. So my name is Fabien Ferrero. I'm professor at Université Côte d'Azur. I'm also part of the company named Montaigne, which is a startup. And I'm in charge of the connectivity for this company. So my talk will be about how to deploy a cloud-grade AI anywhere to protect basically your critical assets everywhere on Earth. So basically, the statement of the company start from this number. So we find out that cloud AI, so I mean artificial intelligence based on cloud, can reach 85% of the critical assets. So it includes, of course, everything that you can find in the oil industry or in a wide area. And then if you have no connectivity, you cannot run any cloud AI. So the purpose of Montaigne is to try to solve this issue and to be able to address and to maintain all these critical assets. So of course, usually AI now fails to reach the final frontier, in fact the real world, the ground. First because the networks are limited, so we know here that as soon as you go outside of the city and the main area, you don't have access to any broad network. So cellular covers only 20% of the world, it's fragmented, there is no roaming. Then also so then you cannot run the AI from the cloud. You need to run it on the edge. Now, if you look at the solution to run AI on the edge, it's bulky. Usually, it's power hungry. The hardware and connectivities are quite expensive, and there is no resilience. And then also, if you want to run some efficient AI, you need also good data set. And this is what we see there. We lack of real-world data. We have no multimodal capture, and we need more broadband network to be able to improve the quality of your data sets. So what we propose with Montaigne is to deploy a scalable infrastructure for edge AI. So first, to provide a solution to have a real-time and autonomous inference at a cloud-grade AI models. To provide also resilient connectivity with terrestrial when it's available, but also satellite roaming when terrestrial is not available. And also to provide all the platform to be able to deploy everywhere with an intelligent middleware and to do all the process from the training to the deployment. And also what we are showing here is also we develop some solution to also be able to capture some data, and for example to do image transfer for satellite, to be able also to improve or to continue the training of your model, and also for different type of application. So the product of the company is basically based on two elements. The first one is what we call the IBEX, which is a smart camera. All the processing part for the AI is in this device. So we can provide a cloud-grade AI accuracy. So if you compare with the CPU or GPU, we can provide an efficiency in terms of power with a ratio of 500. So we can really run with just, we can have a continuous inference with just the energy that you can harvest from a small solar panel. So you can see that we are using just a 10 by 10 centimeter solar panel. So we are talking about a very efficient solution. We can run the inference in less than 100 milliseconds. And the device can also act as a relay, so meaning that in addition to the vision, we can also add some sensors all around to enrich the vision that you have on your scene. So this is the Montaigne middleware. So as you can see, we start really from the capture of the data. We can build, train the model, optimize the deployment. And then after the deployment, we have also the solution to continue, of course, the monitoring, the scaling, and also to continue to update your model on site and and also to get data from the deployed sensors to be able to continue the training of the model. So Montaigne is also part of the Edge initiative, which is an open source platform that aims to provide all the platform from the training to the generation of the code optimized for any type of devices. So this is a project jointly funded by Eclipse Foundation, France 2030, and CEA. And then, yeah, with this solution, of course, you can address a lot of different applications that go from pipeline monitoring, rain monitoring, smart road. Of course, a lot of projects can be linked to smart agriculture. For example, we get some project with olive trees to detect the bugs that are appears in the field, to be able to deploy the right amount of spaces to protect your culture. Of course, power cable monitoring, also any application like border and perimeter, so it's very easy for us to detect, for example, people on counting people, detecting intrusion. And also we have, we start all our project from the wildfire detection. So we have been running with several experiments, especially in the Montpellier center of France, multiple devices to detect fire and to be able to send alerts to the firemen. And something which is quite important, for example, when you talk about wildfire detection, first you understand that you need a low latency, so you need to be able to send your alert as soon as possible. And second one, also what we get from the experiment with the firemen is that they are also asking to see an image to be sure that they can confirm that there is really a fire detected. Because, of course, you know, with the sun rising and so on, you may have some false detection. So this is why also we work on this feature to be able to send small image of the detection, so a human can control and say, okay, it's really a fire, we need to send a squad. So this is the device we are providing. So we call it a digital watchman, which is connected everywhere. So it provides, as I mentioned, a global coverage on Earth. We are using direct-to-satellite communication. We have natively a support of multi-orbit, so we are agnostic from the network. We try to provide, depending on the territory of the use case, the most suitable solution, and we can provide then terrestrial and satellite roaming. So when we talk about the connectivity, this type of solution have some very specific requests. So most of the time, we just need a very low, ultra-low data rate because we are just sending the metadata. So we just need to send a few bytes 99% of the time, but we need to maintain the model, the AI model on the device updated. So something like one time a month, we need to be able to do some downlink with a few kilobytes of data. And also, as you understand, we need also to enforce the model and to take samples from the device to continue to improve the model. So then we need also to update the data set. Usually, when we talk about image, it's from 10 to 50 kilobytes. And then for sending back the data to the network, we can really do it when it's possible. So meaning that we can really optimize the network to use the timing zone where the network is empty to send this data. So we can really optimize the management of the network in this case. The only case where we really need we cannot wait for sending the data is when we send an alert, for example, for for wildfire detection. Then, of course, we need to send the alert as soon as possible. And in this case, we need low latency, but it really depends on the application. So this is why we are exploring. So last week we were in Bonn at Dutch Telecom satellite event, and basically we work with. So it's Dutch Telecom is providing 3GPP and NB-IoT solution through satellites. So they provide a solution with Skylo, which is a geo satellite, but also with LEO satellites, Satellite and OQ. So we have been able to play with it. But initially, we start all the project of the company with EcoStar Mobile. We are providing a very good service for based on S-band. We are also exploring the solution for Myriota, which is also working well. Viasat. And for the LoRaWAN part, there is not only EcoStar Mobile. Lacuna is also providing a good service for S-band communication, which is based not on GEO, but on the MEO satellite. So meaning that, especially they have, for example, a project in Brazil. So for the MEO satellite, you can see the satellite 4 hours a day. So every day at the same time, during 4 hours, you can send you data. So it's not suitable for low latency project, but for multiple projects, it could work. Okay, so and also at Montaigne, we are trying to provide to work specifically on the antenna part, because this is a lot of times a part which is forgotten when you are talking about connectivity. And just to show, so we compare the results we can have with a linear antenna, so the classical antenna that you can get, especially for example in the kit from Dutch Telecom, we get this type of antenna. We compare with some specific antennas that we design which have circular polarization, which are also more directive. So I think also that something which is very important for us is, as we are monitoring a fixed asset, usually, we put the camera, it's not moving. We can also place the device in an oriented direction, so meaning that we can increase the budget link. So we are not talking about big dish to have a huge gain, but we have more directive antenna. And then when we compare typically what we get with a classical linear antenna and what we get with our antenna, we can gain something like, so if we consider in terms of data rate, we can get a ratio of 3 in terms of capacity. So to send an image, we can send it 3 times faster, or we have a, or we can also consider that we can also work at a lower power consumption, and then we can save some power. So, for example, for the same image transfer, if we use a linear antenna, we need to use 27 dBm. If we use our antenna, we can decrease the power consumption to 15 dBm. So we decrease and we improve a lot the efficiency of the network. And when you are running on a solar panel, this is a very important parameter. And so what we did, as you explained, for the wildfire detection, we developed a complete system. So our system is capable, of course, to record the image. Then we can do some coding to, of course, optimize the size of the payload. Then we can cut. So we did this experiment with EcoStar Mobile. So we are cutting the image in small packets, and then we are sending all the packet through the satellites. So of course, I mean, we are benefiting from the huge reflector from the EcoStar Mobile system. So just to tell you, for a classical VGA image, we need to send something like 200 packets with 200 bytes inside. And then after, we can get all the packet from the server, we can move it together and get to image. And we can consider on the connectivity satellite we are using that we need less than 3 minutes to transfer this type of image. Yeah, so yeah, the motto of Montaigne is to say, yes, sky is all we need. Why? Because we need the sky, of course, to get access to the sun, because we need the energy to power our system. And we need also access to the sky to be able to transfer our data, because we are using the satellite. So as soon as you have an application where you can see the sky, you know that our solution can work, and we are able to deploy any type of application that can be needed. Of course, I mentioned a few applications, but think that with AI, you can deploy any type of model that you have been using, can be adapted, and a lot of application can be done with such type of solution. So yeah, thanks a lot. I was maybe a bit short, but I'm very happy if you have some question on this topic. Thanks a lot. Yeah, please.
One obvious question, what's the availability of this product or prototype? Where are you? In other words, can I get my hands on one and take it?
It's a good question. Let's say, you know, we are now prototyping the MVP, and we'll be deploying our first device next year in Q1. But of course, I mean, things that we are going to start with low volume, just to understand also how to fine tune and the system. But let's say that in the next year, this system will be available. Okay. If there is no more question, I think I can stop here. Thanks a lot.